Hello everyone, my name is Rupali Chaure and I am Assistant Professor at SRT College Bhopal, and today we are going to discuss about the topic multiplication algorithm, which is related to the subject computer architecture and organization for the semester 4 of RGPV curriculum. Okay, so let's start the topic of multiplication of two binary numbers. So first of all, I want to explain you how multiplication is done by the paper pencil method. And you can see on the screen, this method is very well familiar to all of you. And we know that how the multiplication is done on pencil, on paper by pencil. So basically what we do, we multiply each and every bit of multiplier to the multiplicand, and then we generate the partial products. These are the partial products, and then we left shift the partial products, one position left shift for each partial product, and then finally we add all the partial products in the at the end to get the multiplication of these two numbers. So same method of multiplication we use for the decimal numbers, and same method is used for the binary numbers. The multiplication of binary number is same as the multiplication of two integer numbers. Okay, so whatever you are seeing on the screen here right now, this method is very easy, and we all know this method for the decimal numbers, and the same method we can use for the binary numbers also. Okay, we generate the partial products, and these partial products are added, and finally we get the result of A multiplied by B. Okay, so how we multiply the given two binary numbers? Now the computer, as we all know that the computer is a very dumb machine. We have to explain each and every step by help of algorithm. So for multiplication process also we will follow an algorithm for multiplication, and as we all know that there are some categories for the representation of binary numbers. The binary numbers which are represented in sign magnitude form for the fixed point representation, we follow this method, whatever we are discussing today. So the multiplication of two sign magnitude numbers in fixed point representation is explained here. The block diagram, which is shown on the screen, is used for the multiplication, which is the hardware requirement for the multiplication of two sign magnitude binary numbers. So here you can see that we have two registers, register A, register B, which are connected to complementer and parallel adder. Again, we have one more register here, Q register, and there is a sequence counter here. And you can see that A, B, and Q register, all the three registers have the sign bit also. AS is the sign bit of A register, BS is the sign bit of B register, QS is the sign bit of Q register. Okay, here E is the overflow bit, which we can say that whenever there will be an overflow after the addition, it will be stored here in the overflow bit. And sequence counter will count the number of partial products generated in the process, in the algorithm, and the register Q. Finally, the register Q and register B, these two registers are used to store the multiplicand and multiplier respectively. So register Q is used to store the multiplicand value, magnitude of the multiplicand, and sign bit of the multiplicand will be stored in the register QS. Same in the same way, the register B will be used to store the value of multiplier, and the sign bit of the multiplier will be stored in the BS bit. Okay. Now, what is the role of register A? Register A is used to store the partial products generated by the parallel adder and complementer. So all the partial products which are generated here in register A, these partial products are added to the register B, and again the new partial product is generated. Again, if the sequence counter is not 0, then again we will add the register B in the partial product, new partial product, and in this way this loop continues until the sequence counter becomes 0. Okay, so and whenever we see that the sequence counter is 0, so the final value of the register A and register Q simultaneously gives the result of the partial product. So now let us see what is the role of this QN bit here, and what is the role of complementer here. Let us discuss about the algorithm in next slide. So this is the step-by-step algorithm explained in the form of flowchart. So flowchart for the multiplication operation of two binary numbers in sign magnitude representation. Okay. So in the first step for multiplication operation, we will store multiplicand in B, then multiplier in Q. As we all know that in sign magnitude representation, magnitude is stored in different register, and the sign bit is stored in the separate 1-bit register. So those sign bits are represented like this by subscript S. So to generate the result, the sign bit of the result, we will XOR the values of multiplier and multiplicand. As we all know that the XOR operation has a table like if we have same inputs for XOR gate, then we will have 0 output, and if we have different bits as an input for the XOR gate, then we will have 1 output for different input. So 0 output for same input and 1 output for the different input. So we all know it very well that for multiplication we need the same result. Like for multiplication of two same sign is the result, it generates a positive result which is 0, and if we will go for the multiplication of two different sign numbers like plus plus, or so like plus minus or minus plus, then it will give a negative number as a multiplication result. So we will take XOR operation to generate the sign bit of the result. So we will get XOR of QS bit and BS bit. We will store it in QS, AS. For QS, sign bit of QS, we will XOR the QS and BS. Now, what is the role of A? A is the partial product as discussed in the previous slide. Here, A register contains a partial product. So initially for the first stage, we will initialize it by the value 0. E is the overflow bit, which will also be 0 for the first step. And sequence counter will be initialized by the value n-1, where n is the size of multiplier, which is q. So size of multiplier is q, hence the sequence counter will be initialized by n-1. After initialization process, we will start our next step in the algorithm, which is checking of the bit qn. What is qn? Qn is the last bit, rightmost bit of the Q register. Each and every time we will check the value of Qn. If the value of Qn is 1, then we will add the partial product and multiply, and we will generate the value EA. If the QN value is 0, then there is no need to add the partial product with multiplier, and we will go directly for the shifting. Okay, so like this here in this pen paper method, you can see easily if the bit is 1, then we will add partial product here. If the bit is 0, then we will add 0. Nothing we will add, we will just shift the number. If the bit is 1, we will add the number, but we will shift it 2 times in the left side. But the process is explained here. What we can do, we can also do that. We can right shift the numbers. We can right shift the numbers to according to their position. So in the same way, we can generate the multiplication method by adding all the partial products one by one in the register A. Okay, so this all process will be continued until the sequence counter value will become 0. As soon as the sequence counter becomes 0, the multiplication process will end, and the result of the multiplication will be stored in the register AQ. If the sequence counter is not equal to 0, then again we will go for the checking of bit QN. Okay, so this is the process of multiplication, and this is the step-by-step method explained by one example. Here we have multiplicand B 10111 in register B, multiplier in 10011 in Q register. In the first stage, we have initialized E and A as 0, and sequence counter by Q, the length of the Q register, which is including sign bit. So it is 6-bit register QN, Q register, but the n-1 will be 5. So in the starting first step will be, we will check this last bit, Q rightmost bit of the Q register, which is 1. So we will add multiplicand the value of B here. The addition will be generated by the binary addition method. And after getting the addition, we will right shift the register EAQ by 1 bit. So by shifting right EAQ, we will get this number. And after shifting, we will decrement the sequence counter by 1. Again, we will check the value of QN bit. This is 1 again. So we will add the B value here. Then we will again right shift the value by 1 bit. This is the result. Now the QN bit is 0. So no need to add the B. We just right shift the value. So this is the value after the right shift operation by 1 bit. And the sequence counter will be decremented by 1. Again, we will have to check the value of QN, which is 0. This 0 indicates that no need to add the P register. Direct right shift operation will be applied. After right shifting and decrementing the sequence counter value, we will get here sequence counter 1, and the QN bit now will be 1. So if the QN bit is 1, we add the value of B register here to generate new partial product. So our fifth partial product is this. For fifth partial product, after generating the fifth partial product, we will right shift the value of EAQ. So we will get this value and decrement the sequence counter by 1, which will be 0. Sequence counter will be 0. So as soon as the sequence counter becomes 0, the value of the register AQ will be the final product. So this is the step-by-step process which we follow for the multiplication of two sign magnitude numbers. Like this, you can also do in your notebooks. You can write down the algorithm in the flowchart form. This flowchart will help you to run the algorithm step by step, and you can easily execute the flowchart. And finally, here you can see that register AQ has the product multiplication of the given two numbers. Okay, here sequence counter is written in decimal numbers. You can write in binary numbers. This is the number of repetitions, number of loops which we are using to generate the partial product values. Okay, so as the sequence counter becomes 0, we will get the final product value here. Okay, so this was the process which we follow to generate the multiplication of two signed binary numbers, signed magnitude binary numbers. So in the next lecture, we will learn about 2's complement representation of binary numbers and their multiplication method. Okay, so thank you very much. Stay tuned, keep learning. Thank you.